It's life, but not as we know it. The American genetics pioneer Craig Venter is trying to create the world's first synthetic life form using the building blocks of DNA. Critics warn there's a huge risk that the microbes could escape into the environment or be used to make bioweapons. But Dr. Venter says they could be used to tackle some dangers like global warming and drug-resistant superbugs. Here's our science correspondent, Julian Rush.
Nearly every day now, scientists announce they've deciphered the genetic code of yet another organism. We know the DNA, the building blocks of life, from a human to a humble bacterium. So the logical next step is to go the other way, to assemble the genes into man-made life forms designed to perform a specific job. Welcome to the world of synthetic biology.
It's like taking a jumbo jet apart and putting all the pieces in a big hangar and then saying, well, you know, how do you reconstruct that into the jumbo jet? And that's actually a very difficult task. So biology is at that point now. It's at the point where it has the components.
We would say in a somewhat grandiose way, but I actually really believe this, that this could absolutely produce the third industrial revolution. And essentially where we were at the end of the 19th century, at the cusp of producing the great industries of the 20th century, you know, electronics, computing, aircraft, the automotive industry, I actually think that these techniques may well pan out to produce the equivalent industries in this century, but they'll be biologically based.
Yeah, absolutely.
One of the front runners in the field is a man who's rarely described as just a scientist. Craig Venter comes with the word maverick attached. It's an epithet earned after his bitter race with publicly funded scientists to decode the human genome. Venter, from the private sector, accused, he says, unjustly, of wanting to patent the human genome for personal gain. He now leads a team that includes a couple of Nobel Prize winners who recently demonstrated they could change the species of a bacterium by transplanting a chromosome into it. That was the difficult bit, he says. The final step is easy and not far off.
To me as a scientist, that's a minor technical issue. DNA is DNA, whether we made it in the lab or isolated it from a cell. The fact that the chromosome transplant now works and has probably existed for millions, if not billions of years in evolution as a key way of making new species, I think is probably the most important aspect of this. We do know how to make large pieces of DNA. My answer is still the same. We do not have it yet in the lab, and we're at least weeks and probably months away from having it.
Venter calls the synthetic bacterium he's trying to create Mycoplasma laboratorium. His team started by sequencing the genome of a simple common bacterium to get its genetic code. Then, using standard chemistry and off-the-shelf DNA sequences, they've created artificial copies of all the genes. And he says they've already succeeded in joining them all up to make a synthetic, identical copy of the bacterium's DNA. All he has left to do is actually insert it into a bacterial cell and hope it takes over and reproduces itself, which would mean it was a living organism, completely artificially created. Both Venter and British scientists in the field believe synthetic biology could help solve problems like climate change. They dream of designer bugs, for example, that digest waste to make biofuels. As for those fears, bioterrorists could create designer bioweapons, so the science needs to be controlled and regulated. Well, the debate on that has only just begun.
Julian Rush. So when I spoke to Dr. Venter today, I began by asking him how he could know what impact would be of implanting artificially created DNA into bacteria.
All we can do at this stage is mimic what's already known in biology. We're making a chemical version of a chromosome that already exists naturally with some minor variations to make sure it can't live outside of the laboratory, it can't infect anything, and it has unique watermarks, so in fact we can prove that it was made in the laboratory. Those are the only differences now.
Well, those are the greatest worries, aren't they? That it might in some way escape your hands and become a threat.
Well, these are some people's worries.
Well, an outsider, a non-scientist, right. Yeah. Is going to be worried that you've created something which you can't entirely control and which might in some way develop into something else.
Those are people who get their science backgrounds from movies and books like the Andromeda
Which is the majority of
right?
humankind.
Which is not the understanding in the biological community where we understand these things. So for the last 30 years, there's been probably 10 million molecular biology experiments done with inserting human genes, plant genes, animal genes, bacterial genes into E. coli that was basically rendered where it would not grow outside the laboratory. And with those tens of millions of experiments, there's never been an Andromeda strain even remotely created. We know what causes infectivity. We're nowhere near infectious organisms with what we're doing.
Let me take you forward 50 years. If you have got what you think you've got, what will the world look like in 50 years' time? What do you think you can do that would change the fortunes of the planet?
Well, I'm hoping I'm here with you in 50 years to have that discussion. Yeah. We have to get off our dependency of taking carbon out of the ground, burning it, and putting it in the atmosphere. It's a bigger threat to humanity probably than any other human endeavor. So if we can use these technologies to come up with renewable sources, capturing the energy from sunlight, sugar into new compounds. We have a new fuel that's in testing that we make from sugar that we think could beat alcohol, butanol, maybe even be one of the first green jet fuels.
And this science that you're talking about is critical to that.
I think it's absolutely critical to biology's contribution to these solutions.
What's to protect humankind from the downside of what you're discovering? What's to protect humankind from getting a hold of the science and manipulating it for evil purposes?
It's a very important question, one that we've been dealing with before the first experiments were done, starting with bioethical review. But the key issue fundamentally is making sure there's good countermeasures for emerging infections. In the US, we've recommended, and they be applied to Europe as well, the companies that make the synthetic DNA, that any request they get be screened for any of the infectious agents, and authorities be notified immediately if anybody's trying to do that. Certainly that would prevent frivolous uses or inadvertent
That sounds
uses.
like self-regulation.
Well, no. In fact, we're happy to have these be imposed as government rules controlling the industry that makes synthetic DNA. It's not an absolute guarantee. You can buy these machines off of eBay and do it. The only ultimate guarantee for society is if the same issue is emerging infections, if we have good arsenals of antivirals and antibiotics and vaccines, there is no threat of biological warfare. It goes away completely.
Craig Venter. More 4 News coming up at 8. We're back tomorrow at noon, again at 7. Till then, that's Channel 4 News. Good evening.